Hello, everyone, and welcome to this edition of Tech Talk with Dave. We are going to talk today about ICT power systems. Specifically, in this video, we're going to talk about their intelligent distribution management. We're going to talk about the advantages of ICT as compared to power systems without management, and we're going to have a look at a live network here that as we're going along here. MBSI has had a strong relationship with ICT for quite some time now, 3 or 4 years. ICT is unique in the power system for its strategy for telecom and for control systems. It can provide power systems from 300 plus watts up to 12 kilowatts. It can supply voltages from 12 volt DC to 48 volt DC, and we can invert them back to 110 volt if your site is strictly DC only, and you need power supplies for PoE converters or for test equipment, whatever the case happens to be. ICT can supply a positive or negative ground equipment. Typically in the telecom world, it's a positive ground, but lots of systems today are floating, and so positive or negative grounds can be used for some equipment. We can be isolated and protected by fuses or breakers, and the integrated systems can have a battery backup as an option, or on some power supplies, it's a standard feature. We're built in with intelligent charging, where some of the systems will have temperature sensors that can go on the batteries and can vary the rate of charge according to the battery temperature or the room temperature, whatever it happens to be. Very, very, very nice equipment. So the big consideration, whether your site is local or remote access is often difficult. And power supplies never fail at 8 o'clock in the morning. Nope, they always fail at the most inopportune moments. Knowing what the power status is a critical piece of the troubleshooting information. If your technician has to run out to a site because a particular radio or a particular service is down, it's good to know before you leave that the problem is that the power is off, or that the power is on and everything's good, and so then it becomes an equipment issue. So what you're bringing for sparing and for repairs can be very, very different depending on what the problem is. Active monitoring is very important. So we're going to see in just a few minutes here, we're going to see that we have that we can look at the breaker status, we can look at the power supply status in a remote situation. I do not have an SNMP system here today, so I can't demonstrate the MIBs and the OIDs. But needless to say, everything that we're going to look at in the GUI that's coming up here is going to be available also as an OID within the SNMP system. And through this GUI, we can power equipment on and off. We can cycle equipment. We can have watchdogs that maintain network connectivity. We can do many things with the equipment. We're going to see all that in the little demo coming up here in a minute. So let me talk a little bit more about the benefits of remote power management. When you see on ICT the power management module generally has a couple of buttons on it and little set of graphics there. By knowing what's going on in the power system, we can take and avoid an unnecessary site visit. If a technician drives some time, get to a site only to have to cycle the power, it's far better done remotely than it is in person right on the spot. And ICT can be set up so that there's a certain time that it's held off before it turns back on again, or it can be immediate on and off. So we have complete control over every one of our outputs. higher end power supplies can take and maintain and monitor the battery status, can load test, can do many things with the battery system as is required, so that you can have a good understanding of what your power system is doing. And of course, as I mentioned before, it integrates HTML or SNMP protocols to make management over a network. It's intuitive and it's seamless, and it looks, you'll see that the GUI that we're going to look at here is going to look like the power supply itself. We'll see everything listed, we'll see the labels, everything else. All right, so the device that I have here is called a 200 dB. It's a dual bus distribution panel, 6 breakers on either side, bus A and bus B. Bus A and bus B have separate inputs. So on this particular panel that we're going to show here today, I can have 48 volts on one bus. I could have 24 volts or 12 volts on the other bus. And as long as the fact that it's either both positive ground or negative ground means that I is the requirement, and I can take and of course run different voltages, different sides. I have alarm inputs. I have an alarm output from each of the buses. You can see there that I've got a couple of connectors that have a center and normally closed, normally open pins. So whatever my alarm system requires, I can take and bring that alarm to my site monitoring box if I'm doing some kind of security at the site. I can take and equip the panel the way that I want to. If I only need 1 breaker or 2 breakers on bus A and I need 4 breakers on bus B, that's perfectly acceptable. I can fill up the empty spots with blank panels. We're going to see those in a second, and away we go. And we're going to look at a few of the features of this panel. The integrated low voltage disconnect, very, very important. One of the beauties of ICT's product is that I can, in software, set my overload current and my underload current thresholds so that I can get an alarm from either state. And so I should never ever actually pop the breaker, except for maybe in a lightning strike or something like that, where the current is radically raised for whatever reason. But in normal operation, if I needed 2 amps for my device, I could install a 5 amp breaker, which I have installed in the panel here. 5 amp breakers. I can set the overcurrent disconnect to 3 amps. Let's say I need 2. I can set it to 3, and then I can set if my equipment idles at let's say 1 amp, it should never be less than 1 amp. I can set the undercurrent to that 1 amp, and so if the device goes dead on me, I will get an undercurrent alarm. If my device short circuits, I will get an overcurrent alarm, and of course it will be disconnected, but my breaker will not be blown. If there's some momentary problem with the power system, it clears, then my power will be restored because of the fact that it's done in software, not in the hardware breaker itself, where somebody would have to maybe drive to the site and reset the power in that particular case. So let's go to the demo here and see what we have. All right, let me come around the front. So here we have the panel. Off the panel itself, when I'm standing in front of the panel, the distribution panel, I can take and cycle through each one of the breakers. I can see the label that's on the breaker. I can see the IP address that's in the device itself, and of course I can see what the current draw is. I don't have a load on anything right at this moment, but you can see I have 3 breakers of bus B that are on, 3 breakers of bus B that are off, and then over in bus A here, I wanted to take and show what a blank panel looks like. The breakers are hydraulic mechanical breakers. They snap into place. They have a very positive connection into the chassis of the distribution panel, and so once you snap these breakers in, you need to squeeze the breaker on both sides at the same time to be able to pull it back out again. So the breakers are meant to be installed once, and then they're securely in place. The on-off of the breaker is like every breaker that we know. This particular one shows it's a 5 amp. ICT have breakers at 5, 10, 15, 20, 30 amp. And so you can equip your panel with the protection that it needs for, like I mentioned, for that short circuit protection. Now, okay, so let's put this back in. All right, in this case now, for a very basic power system, I have an IntelliCharge 360 watt ICT power supply here that is driving bus B of my panel. I do not have anything connected to bus A, of course, but bus B is being driven off of this this power supply. The power supply comes with either the digital display or not, and in this case mine has the digital display, and so if I were drawing 2 or 3 amps from 48 volts through this, I would see my bar graph showing the current draw that I have right at this very moment. The panel itself shows me what the individual breaker, what the individual current value for each breaker would be, and I go from there. Now, if I want to step up, I can go from the next step up from the IntelliCharge series is the Pro Series power supply, which I have one of those here. This is essentially a higher current version of the IntelliCharge here. I can take and charge batteries with the Pro Series. I can take and this particular one does not have a digital display on it. It shows power, and if I had a fault, ground fault, whatever it happens to be, my LED lights up red here. So I have a green power and a red fault if there's a fault on it. And I can take and, in this particular case, suppose I needed 700 watts on bus A and my 360 watts is okay for my bus B, I can take and use the Pro Series to power the A bus. I can use my IntelliCharge to power the B bus and build my power system as I need it. Now, there's one more step up here that I don't have, and that's the Platinum Series. The Platinum Series power supply goes up to 1500 watts, and there are various options. We're going to talk about those in a minute. But I could take and mix and match all of these with bus A or bus B, so I can have 2 power supplies per dual bus panel. And if I had was building this modularly, I could take and add another distribution bus here, and of course I manage it the same way, and it would have its own IP address, and we talk to it, and that would be your basic ICT power system. We're going to talk about soon here. We're going to talk about some of the hybrid and the modular power supplies, but this would be your basic ICT power system. So let's have a look at the display. So when I log into the panel, in my case here, my little router at the in this setup has given my panel an IP address of 192.168.88.252, and so I just simply log into that IP address with a browser, and here's my display. So in this case, we can see that bus A is all disabled. I don't have any breakers plugged into there, and I've got the bus actually turned off. My Form C alarms are inactive, and on the A side. On the B side now, differentiated by the 2 colors of background. At one point in time, I was using this for my Telrad compact LTE equipment and some Cambium point-to-point 820s. So I can label my breakers with what the equipment is that I'm actually using on that that device. I can take and enable or disable the bus. When I disable the bus, I do not lose connectivity to my panel, but you have to be careful, of course. If you go to disable the bus and your backhaul is actually connected to the bus that you disabled from the site, well, of course, right? It's going to be down, and then that necessitates a drive out to restore that. But I can take and I can turn off an individual breaker. So if I wanted to take and disable a breaker, I can do that. I can do it manually. I can turn it back on again, and there we have it. You can see that the manual override is if the breaker is off, the breaker stays off. Even though I enabled it in software, you can still see that the breaker is off. So and I'm not sure if you can hear the click, but every time I do something here, you can hear the relay in the device turn on or off. All right, so here, let me disable. Okay, we want to take and flip breaker number 1B. So there we are, it's disabled. And all right, that's enough time. I want to turn it back on again. And there we have it. I can turn it back on through software. And of course, I have SNMP OIDs for every one of these functions, so I can do it from my SNMP manager, what's up Gold, whatever you're using. And or I could take and do it from the HTML GUI that we're seeing here. All right. Second, I have a setup. I can take and of course give it an NTP server so that my logs are the correct time. I can name my site. In this case, that's the default. ICT call it the dual bus panel, which in fact it is. And there's my model number, ICT 200DB for dual bus. 12 RC is not voltage, but 12 RC is 12 breaker positions in this particular case. If I wanted to take and enable power cycling, I could take and set a number of seconds that when I software turn the breaker off, it will cycle for this many seconds in the off position, and then it will come back on automatically. I can set that. I can take and set an IP address in here that I want the panel to ping. And if the panel does not hear from this, if I enable this watchdog and the panel does not hear from that, I get a response back from that IP address in 30 minutes, it will take and cycle the management to try to reestablish the communication. And then I can take and turn on data logging here. The output in this particular case from the GUI is going to be a CSV file. I can take and have this. If I'm using an SNMP manager, I can take and bring this OID back home again, and I can take and clear the log. And if I hit save there, then the log will be cleared. All right, so let's look at the bus setup. In this particular case, in my demo here, I am not using bus A. In this case, I am using bus B though. Bus A has no breakers installed in it, so there's nothing to enable. Bus B, now on the other hand, I have breakers installed in bus B, and so first of all, I can give it a name. So in this case, I've given it the name of my Telrad equipment. I can have alarms that are generated by over and under voltages, actually, both over and under. We'll look at under first. At under, I get an alarm when my under voltage threshold falls below 42 volts, and I recover from that alarm. My alarm clears, in other words, when my bus gets above 44 volts. So if I were to turn off my my power supply at this moment, we'd actually see momentarily the alarm as it goes past 42 volts on its way to turning off. I can use this value to activate my Form C contacts, and I can specify an email address that I can take and send an email to that says that that I have a power problem, and it will identify that it's bus B, and of course it'll identify which breaker it is or whatever the case happens to be on a more detailed basis within the email. And of course, there's an SMP trap that gets generated for the alarm generation and the alarm recovery. Now, in cases where, let's say that I've got a problem with the batteries, or maybe got a problem with the technician and a wrench on the batteries, and there's an over voltage situation. Well, I want to protect my equipment from over voltage situation, so I can take and set an over voltage value as well, so that I get an alarm when the threshold on the bus goes above 60 volts. Typically in a situation where I've got batteries, might float the batteries at 52 volts. It's 48 volt system. I float the batteries at 52 volts, and I might equalize the batteries at 55 volts or 54 volts, something like that. And so then if I get above that float value, I want to know about that. And so then I take and I set my my over voltage threshold at that point. In my case here, I've set it to 60 volts. And again, I can activate a Form C contact, and I can elect to send an email out of the panel. And then overcurrent threshold. Generally with the 300 watt power supply here, I don't need to worry about that. But if I had batteries on here, that the IntelliCharge was charging the battery, it's possible from the battery condition that I could supply a lot more current momentarily than what the charger will supply. And so in that case, I want to know also when the bus goes over current. I want to be able to set that threshold. And in my case here, I've got it set to 10 amps. All right, so here I have access to setting my thresholds in the output. So first of all, I can set a label. So let's go over here. So there's a label. My output label is Compact 1000. So that happened to be one of my sectors of my LTE network. If the panel resets, I want to restore the power to whatever the last state was. I can set it to disable the output if there's something happens to the panel, or I can enable, make sure it enables the output every time. In this case, what happens is that if I flip the breaker off, let's say I disabled the power before I reset the panel, well, the power is going to come back in that reset state, in that off state, because I set it off before the panel reset. If the panel were to go down because let's say I don't have battery backup and I lose my mains for some time, the panel goes down, the panel comes back up again. The base state, the loads that were on return on, the loads that were off stay off. So we have that to set as we're going through this. Now, let's suppose I got a situation where I do have a battery backup. My mains go down. Battery backup is good for 6 hours. Well, at some point in time, I'm going to take and have my battery voltage start to decay, and at some point I need to take and maybe I want to take and turn off the non-critical loads so that I can maintain power for the critical loads as long as I can. So let's say, for example, I can turn the sectors down, my point to multipoint sectors down on this site, but I want to take and maintain the point-to-point back haul to this site for as long as possible. So what I can do is that at a particular threshold, I can take and turn that breaker from software off so that it's not drawing the current anymore. So let's say I've got 4 sectors on a site and I've got a backhaul. So I'm using 5 breakers to take and in this particular case, 5 48 volt breakers, and power goes down. I want to take and at 45 volts, let's say, I want to take and turn off the sectors. So I have configured all my sectors to be load shared, to load shed, I should say, not shared, shed, simply by, There we are. They can be load shedding. And so I enable load shedding, and then whatever this threshold is, in this particular case, it's set to 10 volts, which is the factory default. I might set the load shed at 44 volts. And then I want to auto recover. So let's say the power comes back on again, batteries begin to charge. And so I want to wait until maybe 46 volts to turn the multi-point system back on again to start the process up, so I can do that. Now, I mentioned before that I have an over and an undercurrent alarm for each one of the outputs. So I have a 5 amp breaker installed in here, and so there's if my load on this 5 amp breaker were actually 2 amps, I could take and set my overcurrent threshold to, whoops, let's say 3 amps. I set it to 3 amps. And at that point, I need to activate the Form C contact so that I send my alarm to my building security system. I also might want to take and have an email come out when I hit that situation, so that I know that when my system has disconnected at 3 amps, that I have a problem. And then I can select whether or not I just want the alarm, or do I want to disable the output. So I have these wide range of choices that I can do with every single output that I have on my distribution panel. I can do the same thing then with undercurrent. So let's suppose for a second that that my 2 amp load on this would never go below 1 amp. So if it goes below 1 amp, I want to know about it, because something, maybe it's tower top equipment, maybe it's stopped working. So at half an amp, if the undercurrent threshold goes below half an amp, then I have the same. I have an option to activate the alarm contact, and I can send an email then at that point, so that I know that some device up the tower has stopped. It isn't overcurrent, but it's undercurrent, so I can watch both directions to see what's going on here. And then I can take in as I'm setting this up, I can save the settings for this particular channel, go on to the next one, whatever it is. Or maybe I want all of bus B to be these the critical systems. Maybe that's what I've called it. And I can copy these settings to every one of the outputs. Very configurable. Very nice. All right, so the management system of the panel, of course, is a typical Ethernet client, and it's a 10100 interface. It has a MAC address. It can receive its IP address from a DHCP server, or it can be statically assigned. That's up to you. And I can take and specify my ports of my web server that I want to be able to take and access this device on. And then I have my SNMP settings. So I have versions of SNMP that depending on what I'm using. So there I've got version 2 and version 3, or I can set it so that it doesn't matter what the server is. I can enable write access, so that means from my SNMP system, of course, I can change these parameters that I want to. I can enable, disable outputs, that sort of thing. Read and write community, standard stuff. And then for version 3, I have a username and authentication password, that sort of thing. And then, of course, I can send traps to a particular IP address, which is normal in an SNMP system, of course. And the trap has a particular community. In this case, the factory defaults are public and write. Sometimes they're read and write, and then of course you can make them your own, which normally you would do. Here's the email setup. So I specify my SMTP server and port so that I can send an email. And so I can, my recipient email, username, password, all that kind of stuff for your particular email account. And I can get notifications from panel restarts and the network watchdog, which are not related to the outputs or the bus status. So this would be separate from what I'm doing here. All right. My alarm setup. I can take and declare what I want each of the alarm inputs to represent, because these get sent back as traps, of course, the alarm inputs. So it is possible that I could take and send my alarm output from the bus to an alarm input here on my panel, and then have it show up as a particular alarm. When I get a circuit breaker alarm, I can specify whatever the alarm is. I'm going to do something with the Form C contacts, yes or no, and I'm going to send an email, yes or no. So there's my 5 alarm inputs, which are on a little barrier strip at the back of the device here. Now I can specify users for who can access the panel, and in this particular case, I've left this at factory default for anyone here in the company to be able to log into it. So here we have admin with no passwords. Typically, I would pick an administrator name and use a secure password so that I don't get anybody logging in. And the administrator, of course, has rights to everything in the panel. The user, view only access. So I might have my technicians, certain technicians that have administrative access, and certain technicians that have read-only access. So I have the 2 layers of 2 levels of access that I can do from the GUI here. Under maintenance, I can reset the panel. I can take and restore it to full factory defaults. In other words, clear the labels, clear the thresholds, clear the email, everything else. I can import or export the settings. So this manage the settings would be to a configuration file. I can download the configuration file from one panel, and I can take and use it to manage the configuration of another panel. Let's say I've got a dozen sites, and all the breaker outputs are installed in a standard manner, and so I want the same thresholds, the same labels, the same everything. I can do that with there. I can send a test email, and I can take and ping a particular host. So it gives you one ping only. So let's say I want to do 192.168.88.1, which happens to be my gateway for this. And there it is, and it responded in one ping. And so I can see that I've got connectivity to my router. And finally, in this display, I have links that can access me to the manual, and I can download the MIB configuration for this particular device right from the help here, so that if I click this, then it goes to the ICT's website and gets me the MIB file for this particular device with the particular firmware that's installed in the device. And so that's the suite for ICT's intelligent management. So whether it's a power supply, whether it's a modular, or whether it's a hybrid system, the GUIs look the same, and so the functions are the same. So once you get used to some of one particular family of ICT products, the management for the others are very similar. So as you build your network, and as you install power systems at sites, the power systems can look very different. One site could be a hybrid system, one site could be a basic system like this, and from an operation standpoint, they all look the same. So thank you very much. That's a look at ICT's Intelligent Management System, one of the advantages of using ICT as your power supply system.